Hello everyone, thank you very much for being here. In today's session, I'm gonna show you our journey of migrating our production workload to another AWS account. So first thing first, a little bit of things about me. I'm a Node.js developer at eMag. The main technologies that I work with every day are AWS, TypeScript, Terraform, mysql, Apache Solr, Apache Kafka, and Python. And the AWS stack and what you're going to see throughout this presentation are Lambda, RDS, MSK, ECS, CloudWatch, Athena, and S3. So the agenda for today, we start off with the project overview, both technical and business side, and then a strategy plan that we created for this migration, which is divided between compute and storage. The compute part is fairly simple and easy. Then with the storage part, you're going to see it's divided between Redis or elasticache, RDS, S3, and then we wrap it up with Route 53. The migration procedure would be a recap of everything that I described you till then, and if we still have time, a couple of slides about costs. So the project overview. So I am part of the Ads microservice or sponsored product. What we do, so if you go to eMag website, you're going to see there are on the listing page and on the product page these products which have a promoted tag on it. These slots are actually reserved slots for vendors who appear to be there. So your basic sponsor products service. In terms of technical, we have three main parts, or multiple parts, but two main ones and another side one. The API, which is where the vendors are actually coming and making requests to update their campaigns, add offers to their ad campaigns, and whatnot. So basically how it goes, marketplace makes requests through our Route 53. We redirect those requests to API gateway. We call a Lambda function that further writes into RDS, which is mysql, elasticache, Redis, and then MSK, which is the managed Kafka service from AWS. From them, then we consume those events using ECS, and then we republish on some external topics for some other teams. And then we have the ingestion part. So on the website now, the clicks and impressions are being published on an on-premise Kafka cluster. We then using Mirror Maker, we put them in MSK, and then we consume them using ECS. That also writes into elasticache, RDS, and then we send them to Kinesis through Firehose, and we store them in S3 for durability. And some three additional flows that you're going to see are relevant for today's talk. S3 notifications, so external teams are coming and they're uploading files into our S3 bucket. We call a Lambda function that then triggers an ECS task that further writes into RDS. ECS schedulers, so your basic crons that also write into RDS. And then we have the CDC flow. For those of you who are not aware, CDC stands for Change Data Capture, and it means logging all the state events from your application. We do this using a log filter over our log group, CloudWatch log groups. We send them into Kinesis Data Firehose, and then we store them into S3. And then in case there's ever needed for debugging purposes, we use Athena to query that data. And this is 10 terabytes out of the 15 that we had stored in S3 at the time. So the strategy plan for the migration, this is the compute part. So why the compute part was easy was because we had all the infrastructure in Terraform scripts, so we just needed to do some minor tweaks to an account migration branch, like changing names of global resources, because at some point we needed to run the two architectures in parallel, like S3, IAM policies, and API gateway domain names. We then added a new account as a provider in Terraform, and then we changed some Jenkins deployment scripts to use the new account. And then we also created a new workspace for the new account to be able to recreate those resources. And these are, like, when I say compute, is everything that does not have data. Now, moving on to the storage part, we start with elasticache. So your first question may be, why do you need to migrate Redis? Isn't that just a caching system? And the answer is yes and no. So we use Redis to store clicks and impressions to be able to, for the duplication purposes. So basically, we don't want to bill a vendor twice for the same click. So this migration was quite important for the production workload. At first, we try to automate as much as possible. So using a snapshot name being the backup name of the Redis cluster from Terraform. Unfortunately, that didn't work because our Redis data is sharded. And in order for you to migrate your elasticache cluster, you need to provide the key slots for each shard. And Terraform does not have yet the implementation for this, even though the AWS CLI AWS API requires it. So we created some manual steps for this. The first one was just creating a backup. So this is fairly simple to do. You just go to your elasticache cluster, in Actions, Backup, and then in Backups you're going to be able to see your newly created backup. You then export that backup to an S3 bucket from the export button. And then you sync sync meaning copying all the objects from one bucket to another, so that you bring your new backups to the other AWS account. And then you just need to run an AWS CLI Redis cluster creation command that would recreate your Redis cluster from your backup. So the sync command looks like this. The most important part is the grants command, and the first ID that you see there is the canonical ID of the elasticache service, because you basically need to give access to elasticache to use the objects that you migrated. And the second ID is the canonical ID of your account, because your account also needs to have access to those backup files. And this is the cluster creation command, where you specify the snapshot IRNs right here. And you can see it is sharded by the 0 to 1s. And then there's also the node group configuration, which is the option that Terraform did not have. So this is why we couldn't do this in Terraform script. And everything went smoothly with elasticache. Now moving on to the Redis migration, to the RDS migration. For this one, we had night downtime allowed. So basically, we decided to stop all the writes, then creating a final snapshot, sharing that snapshot with a new account, and then recreating the Aurora cluster in the new account from that snapshot. And how you do this? You just go to your RDS cluster, you take a snapshot, you then share the snapshot from Actions, and while sharing the snapshot, you need to provide just your account ID. And then in the new account, in the Shared With Me section, you're going to be able to see and also use the snapshot IRN. The issues that we had with this, so during our testing, it would roughly take 30 minutes to recreate the cluster with a database instance of this size from a specific snapshot. Yet, when we did the actual migration during the nighttime, so it was 2 a.m. in Frankfurt at the time, it would take up to 1 hour. And the AWS support could not tell us if there's anything wrong, so we got really scared at the time. Fortunately, after 1 hour, the database got created, and we could move on with the procedure. This is what I think happened is that during the nighttime, AWS actually scales down the workers for infrastructure creation, although it's not validated, but it's just an assumption. I'm gonna test more to see if this happens in the future as well. Cool, moving on to the S3 migration. So the S3 is divided between replicating new objects and then replicating existing objects. So for replicating new object, cross-account replication, which you're gonna need is a replication role, and then also a new bucket policy in the destination bucket, which is the bucket from your account. So this is how the replication role looks like. In the trust relationships, you need to have the trust identity of S3, And then in the permissions, you will need to have both S3 permissions for your source account and also for your source account S3 bucket and for your destination account S3 bucket. And in the new account, you need to add a bucket policy in which the principal would be the replication rule that you created earlier. Issue is that replication does not propagate. So if your object gets replicated by replication rule number 1, it will not get replicated by replication rule number 2. So you will need to tackle this your own. And you can do this using replicating existing objects and also replicating all the objects that were created before the replication rule existed. So there's two strategies for this. We're gonna start with a sync command, which actually does this. So it compares the two buckets and it brings in your destination bucket every object that does not exist, every object that is in the source bucket and does not exist in the destination bucket. It also only copies the current version of the object. So if in your S3 bucket you have versioning enabled and if you have replication rules, it's only gonna bring the current version of the object while changing the version ID and also the last modified value of the field. So the last modified value of the field would be the time at which you ran the sync command, not the time at which you created that version. Cool. So we ran the sync command. This is a basic CLI command, and after 2 hours we decided to run some Athena queries to see if everything is working right. And we got hit with this error. And when we went to the objects in S3, we've seen this, which means that your account does not have access to those objects. And if you remember from the Redis slide, you need to add the grants command and give the canonical ID of your account so that your account is able to use those objects. And yeah, this is how you get the canonical ID of your account. You just go to an S3 bucket from that account, and you're gonna see it. There. And how we decided to fix this is we went on to delete all the files in the bucket, and then start clean with a batch process. Why we decided to ditch the sync command is because it was taking a lot of time. It was very hard to follow and to track the progress and to see the errors. So the batch process, and you're gonna see the advantages in a bit, is working a little bit differently. So if you ever set up a replication rule in S3, you've seen that a pop-up is gonna appear asking you if you want to replicate existing objects. If you click yes, it's gonna redirect you to the interface, to the batch operations. And what these batch operations are doing, they're actually scanning all the replication rules that you have in your account, and they take all of the active replication rules and they replicate all the objects that were created before the replication rules existed. It's copying all the versions. So it's copying all the versions, it's keeping the version IDs, and also the last modified field becomes intact. So the last modified field will not take the value of the time at which you run the batch process. It will keep the value at which the version was created. A couple, not necessarily issues, but this is how this process works, is that it's if your replication rule was inactive at a certain period in time, it will not take those objects. So you're gonna need to tackle those objects on your own. And it's also gonna take all the active replication rules. So you cannot specify if you only want a specific replication rules. You're gonna need to either inactivate it or find some other workaround around this. Cool, quiz time. So there's a sweet treat for anyone who is gonna guess if there's anything wrong with this sequence of events. So I'm gonna remind you a little bit, is that first we ran a sync command, then we figured out we messed up, we deleted all the files in the bucket, and then we ran the batch command. Can you foresee anything that might have happened with this sequence of events? I left a couple of hints along the way with the chocolate. It was placed on the version, yes, and it did, yes, and when we run the batch command, what happened? No, it was not an error. It was more like it was intended to. But you're close with the delete marker. Yeah.
It only copied the previous version because the first time the same copied the latest version, then you deleted them, but the data somehow was left, metadata was left there, and it only copied from the original bucket the older version.
Yeah, exactly. Thank you. You can, yeah. And there's also a prize for you, though. I have a second prize, but yeah, congratulations. So I'm gonna explain to all of you what actually happened with an example. So first time it was the sync command on 5th of December, and we ran the sync command. Then on 9th of December, we figured out we messed up and we went on to delete all the objects in the bucket. But because the buckets are versioned, you don't actually delete them, you just add a delete marker on them. And then on 10th of December, we ran the batch command. And because, as I told you, the batch command is actually keeping the last modified field intact, this was, it would not be the current version. So when we ran Athena queries and we were looking into our S3 bucket, the current version was the delete marker from the delete that we did. It is clear? I hope it is clear with example. This was fascinating to us when we've seen it. So how we fixed this? Because there were only a couple of objects affected, we decided to run a second sync command and fix only the prefixes of those objects that were affected. And after all of these mistakes, how do you check if everything is in sync with S3, right? So we went on to the monitoring tab, and we were seeing that there was this 800K difference, object difference, in the monitoring tab. Yet, when we use the calculate total size metric in S3, we would not see such a difference. And the reason is because the bucket object count metrics takes versioning into consideration, while the calculate total size option does not. So if you take in the 800, so when we calculated from the last slide, this object difference multiplied by 2 or 3, so the number of versions that we added, it was adding up. So yeah, this is how it's working. This is an example that I created for you just to be more clear with less objects. So you see calculate total size option is showing 7 objects here, while this metric is showing 16. So just for you to know in case you ever need to use these metrics together, how they work. And then the cleanup, because now we need to delete the S3 bucket from the old account, right? But you cannot delete an S3 bucket if you don't empty it first, right? So how do you empty an S3 bucket with 15 terabytes of data? Well, you first start to go to the interface and you try the empty command. But the empty command is actually working only if you have an active session. And for 15 terabytes of data, you're gonna guess that your session is gonna be refreshed a lot. So what you do is set up S3 policies, lifecycle policies. So the first one, this is an example that I'm gonna demonstrate to you, is expire current versions of the objects, which is basically gonna add a delete marker on your object. And then the second one, permanently delete non-current versions, is just gonna delete all the non-current version. Just one mention, don't add anything here, because if you add one, it's gonna keep one non-current version, and the next policy that I'm gonna show you, it's not gonna work. And then the second lifecycle policy that you need to set up, delete expired object delete markers, which is just gonna delete the delete marker. And voila, in 2 days, you have a completely empty S3 bucket. Cool. All clear to now? The hard part is almost over. Route 53 is another hard part, and then it's just a recap. So this is the setup for the Route 53. In the old account, we have a hosted zone that it has one subdomain who actually points to an API gateway, and then the other subdomains are just pointing to Elastic Load Balancers. And in the new account, we had to set up another 2 hosted zones. So one that would have the subdomains similar to what we have in the old account that were pointing to the Elastic Load Balancers. And then the second one is having another hosted zone that was pointing to the API gateway. The reason we needed another hosted zone is, if you remember, the API gateway domain name needs to be unique across all accounts. So we had to change the URL of our application and ask the marketplace team to do the release with us, because we changed the actual URL. So this is how we started the migration. We first pointed in the old account, we pointed to the Elastic Load Balancer from the new account, and then we removed the old subdomain, added the new subdomain, and pointed it to the name servers in the hosted zone in the new account. And then after, I think 2 days, it was the TTL for us, we just decommissioned the old hosted zone so that we could move on. Cool. Whew, the hard part is over. I hope you're not too exhausted at this point, but as I told you, this slide is just a recap of everything that we've discussed. So the migration procedure happened at 2 a.m. in the morning, a day after my engagement. It was a perfect engagement gift that nothing broke and everything went fine. So yeah, let's see how we started. Each of us got assigned a country. And then we started with deleting the API key to prevent all the writes from the API. And then we set the consumers to 0. And also we removed the auto-scaling policies to make sure consumers would not be spawned. So that, we stopped all the writes from elasticache and RDS from there as well. We removed the S3 notifications. We also announced beforehand the teams that please don't upload anything in the bucket during this window because we're doing the migration. What happened? I'm not sure why. I think it's... Check my laptop. Okay. No, it's working fine. I'm not sure what's with that picture there because it seems like doubled. So yeah, that's why. 1 second. Okay, now it's looking good. Okay, cool. Let me go a little bit back. Yeah, so we also stopped the schedulers, and I think that's it. And that's how we prevent all the writes. We created the Redis snapshots, Redis backups, and also the RDS final snapshots. And then we exported them, exported the snapshots, and also exported the elasticache backups. And then in a new account, we created the Redis manually. We hit Terraform apply only for RDS to recreate our database from the snapshots. And then we hit Terraform apply with the pre-migration branch to recreate all the compute resources. Why the pre-migration branch? So the pre-migration branch would be similar to what we did previously. So schedulers off, consumers off, no S3 notifications, and no API key just yet. Okay, this is getting frustrating. I'm not sure why this is. I think it has way too many animations. Okay. Anyway, I'm gonna try to remember everything. Then we but I okay. Now it seems to be working, right? No, not yet. Please. Okay, just look at the slide like this. We gradually started all of the consumers while monitoring the RDS CPU load to make sure the log is consumed in a proper way. Once the log was consumed on Kafka, we asked the marketplace team to do the release with us for the switch. Then we, after some monitoring to make sure everything is working fine, we released the main branch with the consumers, auto-scaling policies, schedulers, and also the notifications being on. We checked if there was any scheduler that should have run during the migration procedure, and we ran it manually. And then we asked the teams to upload to the new S3 bucket. Yeah, okay. Come on. Okay, let me see if I can present from here. Mm, don't I have present from this slide, really? Okay, let's hope it will work this time. This is another recap in case you needed it. And then we went to sleep, by the way. This is how we did it. How much time do I have left? 5 minutes? Perfect. We still have time for the cost. I guess everyone is wondering how much did this cost, right? Okay, let's see. Mm. Yeah, a lot of animations, I know. There's Route 53 there, the migration procedure, and how it should have worked. And then we went to sleep. Cool. So the cost, S3 in the new account, you see the majority of the costs here are coming from the Glacier. Why? Because we also have an S3 bucket in the disaster recovery region that is a backup S3 bucket. And Glacier, so Glacier data storage, tier 1 requests, meaning request for upload and creation of the objects, and also GET requests, because we needed to recreate that bucket as well. So that's why it was very expensive. In the old account, the majority of requests were tier 2 meaning GET requests, because we're needing to copy the data. In terms of RDS, we didn't see any significant costs. The costs that you see left over here are from some snapshots that we decided to leave in the old account. And in terms of the new account, again, nothing in particular. The costs that you see before the migration, so the migration was in December, were because we were running another application in the new account at the time. In terms of elasticache, no additional costs. So the spike that you see here is there is actually Black Friday, because we scale everything up during that period. And also no further additional costs in the new account. And the total amount would be $2,700 plus 36 man days, which I think were more expensive than the AWS bill. So yeah. Just a remark, I've heard from someone that you can get in touch with your account manager, because some of these costs may be covered by AWS as well. So you can benefit from that. And with this, thank you very much for being here. I hope you like it, and I hope you learned something new. And in case you like challenges like this, we have a Node.js opening position, so feel free to apply if you enjoy. Thank you. Do I have time for questions? If you have any questions, I'll be more than happy to answer. Yeah? Yes, so previously all the teams in eMag were in the same AWS account, and we would have permissions. For instance, I was able to go to the Genius team and just delete their clusters if I wanted to, and it was not very like in terms of permissions, not okay. And also in terms of costs, it's much more easier to manage costs, to see your costs in your separate account than in a shared account. So for permissions and cost operations. Thank you. We had tag-based permissions, but it's still much more reliable this way. For costs or for
example, we run production workloads in an account, but for example, like my team manages application A,
Mhm.
and we have like a team tag, and our IAM policies allow us only to and the security policies allow us only to do stuff on the role. Like if I log in like with role for team A, I'm able to do only stuff for team A. I cannot delete or stop a cluster for team B.
Mhm. But isn't this more complicated to create general, like to create very granular permission rather than to have every project in its own account?
Then we'll end up as another company that we have that has more than 2,000 AWS accounts which run workloads in like each application has its own account and each team has, and we have like 2,000 AWS accounts for everything.
Ah, understand. Yeah, for us it's much more easier this way. Yeah.
Why did you create the Redis cluster manual and why not use the
Because the Redis cluster it was sharded, and in Terraform there is that bug in which you cannot, if you can specify the snapshot IRN, but you need to specify the key slots for each shard, and you cannot do that because it's an open bug. So we couldn't add it in Terraform.
Have you considered replicating the database like a master slave or main? Use like DMS migration for.
We were looking into it, like having a writer-to-writer configuration, but it was very difficult, and truthfully, the vendors are not updating their campaigns during the nighttime, so the downtime was not such an inconvenience to us. It was much more easier just to move on and focus on how to migrate the S3 bucket rather than looking into that. Yeah. Sometimes you gotta pick your battles. Cool. Any other questions? Thank you very much.